Welcome to what will hopefully be my first and last related rates review. So, we're going to be covering day 1, 2, 3, and then the review. Any external questions are not going to be covered just because I don't have the capacity to do those elsewhere. But we're going to try to just go through the review problems first and then move towards the more challenging homework problems, and then hopefully I'll be able to answer any questions that might be unsolved. Okay, so we'll start off with question 2 on the review, which says, oil spilled from a ruptured tanker spreads in a circle whose area increases at a constant rate of square miles per hour. That's pretty important, so I'm going to write that down. The rate of change for the area is equal to 6 squared miles per hour, or square miles per hour, which means we're going to write that as miles squared per hour. Alright, perfect. How fast is the radius of the spill increasing when the area is 9 square miles? So that means I need to find dr dt, or the rate of change for the radius, when the area, or when A, is equal to 9 square miles, which is to say that I need to find that. Alright, so first and foremost, it tells us that the oil spilled from a ruptured tank spreads in a circle. And because it tells us that it's the area, we know that the area equation for a circle is equal to pi r squared. That is because pi is the entirety of the external part of the triangle, and then radius is the inside squared. So, a couple things to note here. We need to find r. We need to locate what r is, because it does not give us a radius. Nowhere in the problem does it specifically tell us a radius or a diameter. So we do not know these values. We have to find these values. So first and foremost, we're going to need to set up 2 separate equations of the same kind. We're going to need to set up one, a equals pi r squared. And this will be our ability to find r. And then we'll set up a separate one to locate dr dt, because that is important. All right, just move so I have more space here. Okay, so first and foremost, I'm going to solve for r. There's a couple ways you can do this, but I'm going to first substitute in 9 meters, or 9 miles per second, or 9 miles squared, and set that equal to the equation I have for the area of a circle. Then I like to divide by pi first, but obviously there's many ways you could do this. I'm going to divide by pi on both sides, and that will get me 9 over pi is equal to r squared, and from there I can just square root both sides, and I will end up with 3 over square root of pi equals r. So now we have a value of r. Now we actually know what r is. So now we need to implicitly differentiate. This is where we're going to take our values and find the derivative of them. So this will become derivative of a dt, the rate of change for area over time, is equal to power rule. So this will be dragged over here, 2 pi subtracting 1 times the inside function, which would be dr dt. Now we're solving for dr dt. So now, right now, I need to substitute in what I know. So as we learned from the above part of the equation, the rate of change of the circle is 6. So I'm going to put that in. I'm going to plug 6 in here. And we also learned, well, we also have or found what r is. R is 3 over square root of pi. So I'm going to also substitute that in. 3 over square root of pi. And then I'm just going to leave dr dt on this side. Okay, so now I need to simplify, because obviously we're solving for dr dt. So I need to make things so much easier for myself to solve. So automatically, I can see that I can multiply 2 pi up top which will get me 6 equals 6 pi over the square root of pi. And then dr dt. And I'll put this one in parentheses because I'm going to try to separate that. The parentheses aren't important though. Now I'm noticing that I have pi and square root of pi. Now, this is a rather tricky thing, and you could really just there's no real right way to really look at this other than the fact that this will be helpful if you understand how squares work, because the square root of pi is equivalent to, hold on a minute, how do I explain this? The square root of pi squared is equivalent to pi, because that will cancel out the square roots. If I'm dividing a whole by a radical, it will just equal that radical again. Because if these two were to be multiplied, it would equal this up top. So now I have 6 is equal to 6 square root of pi dr dt. And now I'm just going to divide by 6 square root of pi on both sides. And from there, we have found dr dt to be 6 over 6 square root of pi, otherwise known as 1 over square root of pi. And then we obviously need to put a unit on it, because we can't end it off with a unit. We've been given units. So because we know that this is the radius, or the rate at the radius changes, that means it's going to be a fraction-based unit. It's going to have something up top and something up bottom. And because we were given a unit of miles earlier as a distance, and hours as a measurement of time, we can put miles per hour here. All right, so that is review question number 2. I'm just gonna clear the board here. And we're gonna go back. So we're gonna do we're gonna skip question 3 because I think question 3 isn't too difficult. If need be, let me know tomorrow and I can also run through question 3. I'm actually gonna do a couple of these related rates problems, or the similar triangle problems. So let's go on to number 4 of the review. It says a conical water tank with a vertex down, which is to say that the point of the vertex is down, has a radius of 10 feet, radius equaling 10 feet. I'm gonna write that down. I'm gonna get rid of this because I don't want this clogging up space that we don't need. Oh, yeah. And at the top, so that will be at the top here, and is 24 feet high, which is to say that the height, or the initial height, is equal to 24 feet. Great. If water flows into the tank at a rate of 20 feet cubed per minute, which is to say that if the volume of the tank, oh, that's not the volume of the tank, is it? I have to remember. Yes, it is the volume of the tank. Wow. If the rate of change of the volume of the tank is equivalent to 20 feet cubed per minute, what is the depth of the water, also known as the rate of change of the height of the water? Or how fast is the depth of the water increasing, which is going to tell us that it needs to be some sort of positive value when the water is 16 feet deep. And this means that we need to find it if h, or if our new h value, let's call this h2, h subset 2, is equal to 16 feet. Okay, so First and foremost, I'm going to draw a picture. I think it's the most helpful way to do any of these problems is to start off with a picture, just kind of understanding what you're looking for. So it told me that the vertex is downward, which means that it's going to be an upside down triangle as a cone. And because it's a cone, it's going to have a circular base, which is great. So first and foremost, I'm going to write out a couple things. I'm going to first write down what the equation of a cone's volume is, because I like to start off with the equations first. So I'm going to write the volume of a cone is equal to 1/3 pi r squared h. And this is because it's 1/3 of essentially a cylinder. That's the cylinder formula almost. Or that is the cylinder formula. Except I think it's missing a 2. And then just 1/3. So here we are. We have our equation. And then next I'm going to do some recognition. So one thing I know about a cone is that it happens to have 2 right triangles. And this is not going to look as great on your side as my side, but it has 2 right triangles right here. That's a right angle. So I know that if the height of the cone is 24 feet and that the radius of the cone is 10 feet, and that it's asking me to find what essentially the rate of change of the height would be at a new cone within the cone, I'm going to look at it instead of like trying to solve cones within cones in terms of triangles. This is what we learned, which is called similar triangles. So now I have a triangle set up, and I'll just draw it outward as it should be, kind of like that. That is 10 as an x value, I guess you would say, a, whatever you want to call it, and 24 in height, or whatever else you would like to call it, y. I also know that within this triangle, there is a similar triangle. I'm going to draw that and then move it over so I can actually do some comparison with it, because I think that's important. So there I go. I have a smaller, similar triangle, because these angles are ideally the same. I'm going to label my height h and my radius r, just because I don't want to plug anything in yet. I don't want to start plugging things in until I have a real formulated equation. So you may be tempted to plug in h, or to plug in 16 right here and be done, but that's not going to help out in the later part of the equation. You'll see why we need to have h. So I'm going to solve for r, because that is one of the only values we're really missing, that one that we don't know. So we can set up a ratio. 10/24 is equal to r over h. Cross multiply, so this will become 24r is equal to 10h. And then I'm going to, since I'm solving for a radius, I'm going to divide by 24 on both sides, which will get me r is equal to 5/12, simplified because you can divide both of these by 2h. I'm going to leave on the h on the outside, just because I want it to be easier to simplify later. Okay. So now, I'm going to take this volume equation, and I'm going to put it in terms of derivatives. I'm going to implicitly differentiate it. So first and foremost, I'm going to plug in this r value, just because I want everything to be in terms of h, not r. This is because if I were to do it with r, I would get dv dt is equal to, and I don't even want to do this just because that involves me having to do product rule here, but I would end up having dr dt, and we don't know dr dt. The problem does not provide dr dt. The problem doesn't give us any reasonable clues to solve dr dt. We don't know how to solve dr dt within the confines of what the problem is asking us. So we don't want r, because r is going to give us a major headache, and we're never going to be able to solve this problem with it. Instead, I'm going to substitute in first. So I'm going to substitute in my h value, or what I found is my r value. And I'm just going to undo that because I made a big dumbo decision. And I'm gonna do it again, aren't I? Yes, I am. And this will be 5 over 12 h squared. You can't drop the squared. That's important. H. Okay, so first I want to simplify this because I don't want to have to deal with that. That's still going to be product rule. And that's not going to be very fun. So I'm going to simplify this to 1 over 3 pi. And then if I were to carry the square in, that would be 25 over 144 h squared times h. But because we have the h on the outside and because we can just simplify it, this would actually just be h to the 3. So now we have an equation that we can implicitly differentiate because these are constants and this is actually just another part of the problem. Alright, so let's set it equal. So let's implicitly differentiate. That'll be dv dt is equal to carry the 3 over. So if it's 3 over 3, that's just going to equal 1, which means it essentially becomes irrelevant to the problem. We no longer need this part here because this is no longer here. Pi, I'm going to move the pi into the fraction just to make my life a little easier and to be able to see things easier. 144 h to the second dh dt because we have to multiply by the inner part of this function. Okay, so now we have everything implicitly differentiated. Before I move forward with that, I'm going to plug in h because I know an h now. I have h2 now. So now everything is implicitly differentiated. We just need to actually start simplifying because we need to solve for dh dt. We can't have this here. We want to have strict values here. So I'm going to plug it in, and this, I'm not going to really show me actually like simplifying that out, but that looks awesome. And this will become 256. That's 16 squared. You have calculators. If not, 16 over 16. Or remember to multiply like that, but I'm not going to showcase that. dh over dt. All right, perfect. So now we have. Oh, I don't want to move that. I just want to move down. Now we have a real equation. Before you do anything, you're going to want to move this up here. So this would become dv dt is equal to, and I'm not that good at math beyond like the hundreds, so just going to pull out my calculator and just simplify it for me. That would be, what is it, something like, measure this. I'm also going to, let me just scroll back up real quick. We know dv dt, so I'm going to plug that in now. I know it's kind of dumb that I plugged it in now. You can plug it in earlier, but it doesn't really change what you should be doing. So this will become 20 is equal to 6,400 pi, don't forget the pi, over 144. And you might be asking why I didn't distribute, because I only need to multiply to the top. That's how fractions work with this, or just in general. So now I have a really nice looking set. So first and foremost, need to cancel this out. So I'm going to multiply both sides by 144. Just to get it out of the way. So that will be 20 times 144. That's going to be 2,880 is equal to 6,000, oh my gosh, 400 pi dh dt. And assuming your algebra levels are here, where we've been for a lot of calculus, you should know that this is the part where you will be dividing. So you're going to divide by 6,400 pi on both sides. This is where discretion comes into play. If you wanted to, you could very well divide, call it a day, and you would get an answer. And your answer would be accurate. However, for the sake of simplicity and also because I think it's better to keep everything within the scope of radians, just because I don't want to have to deal with decimal places and the inaccuracies that come with them, I'm going to simplify this. So first and foremost, I'm going to try and see if my calculator can simplify this fraction. And yes, you could most definitely simplify the fraction without needing a calculator. But I'm, like many of you, am lazy and do not want to have to go through that time. So I'm going to simply plug it in, and I know, or I can find out, that 2,880 divided by 6,400 can actually be simplified down to 9 over 20. And I'm going to put the pi on the outside, just because it's easier now that I don't have anything here. So now I have something, but I need to add units. So I'm going to look back up, and I'm going to remember for my problem that the distance we looked at was feet. And I'm also going to notice, or at least try to find out, what time. We use time in measurements of minutes. So that means that because this is a flat rate, which is to say that if the area was squared, this is one segment of that area, so that would make it a flat rate. I'm going to write feet, after I conspicuously scroll down, feet per minute, and that is question 4. The last one I'm going to tackle on the backside of the review before I move on to homework questions is going to be number 7. If you want help with number 5, feel free to ask me in class, but I think number 7 is the one that's going to be the most tricky for people. So we're going to start with that. So I'm going to scroll in here. All right, perfect. So we're going to start with number 7. All right, so let's read. A particle is moving along the curve 16 squared. I'm going to write this down because I like to have this equation especially. Once it gives you an equation, it's good to have it written down so you can just reference it later without having to go back to the problem. 16x squared plus 9y squared is equal to 144. Find all points x and y, so we need to find an x and y, at which the rates of change of x and y with respect to time are equal. That is to say that the rate of change of x with respect to time is equal to the rate of change of y with respect to time. These are going to be equal. They're equivalent. So, like last time, or the first problem I set up, I'm going to set up 2 separate equations of the same kind. I'm going to set one up so I can find one value, and then I'm going to plug it in and then find it, except I'm going to start with implicit differentiation. So I'm going to write the formula one more time. Plus 9y squared equals 144. And first, I'm going to implicitly differentiate. So I'm going to carry the 2. That's going to be 32x, multiplying the inside, dx dt, plus 18 dy dt. Hold on. I'm missing something. I'm missing a y. dy dt equals 0 because it's a constant. All right, perfect. Now, this is kind of where your knowledge of how this will work. Because these are equivalent, because this could be 0 equals 0 or 1 equals 1. That's a 1. That's not supposed to be a 0. They essentially become irrelevant to our equation. I can just boop, boop, because you don't need them anymore. They are no longer relevant to our part. We don't need to solve with them. So now we just have 32x plus 18y is equal to 0. So now we're just at calc, or essentially algebra. I'm going to minus 18y from both sides. End up with 32x is equal to negative 18y. And I mean, you could do this the other way. but I'm going to solve for x first before I solve for y, just because it makes more sense to me. And then I'm going to divide by 32 on both sides. And if you remember that you can divide by 2 with both of these, then you will get that x is equal to negative 9 over, what is this, 16 y. Cool. So now we have our x value. So now I'm going to move over here, and I'm going to write out and solve for the y value. So I'm going to just write out the same equation, but this time I actually know what my x is. So I'm just going to plug that in. I'm just going to say 16 negative 9 over 16 y squared plus y squared equals 144. Now, you're going to be tempted to multiply in first. Believe me, I was too. But we're not going to multiply. First, we're going to distribute these squares. So this will become 16 81 over 256 y squared. I'm going to move the y squared to the outside just because I want it to look easier to read. Plus 9 squared equals 144. Next, now I can actually multiply. So this will become a 1. This will become a 16. I'm not tweaking, am I? Hold on, I'm kidding. Haha. I had to recheck my work. I had to look back. Okay. So that's not right. This is right. I did this right. Part of being on cameras, I'm not going to switch. I'm actually just gonna bring it in. So I'm gonna multiply 16 times 81, 1,296 over 256. And that would be 16 or 81 over 256. Wow, I just really contradicted myself for no reason, didn't I? Yeah, I did. Oh, the woes of of teaching. 9y squared equals 144. So, here's the good news. You're basically close to done. You just need to combine like terms. Here's the sad news. Combining like terms is kind of annoying here because you have to do fractions, but there's an easy way to do this. Because this is the denominator, you just need to multiply by the top. So that'll be 9 times 81, which will get you 729, divided by 256. That doesn't simplify, does it? No, wait. Haha. That's 9 times 256 plus 81. And then dividing by 256, right? Why is this not doing it for me? What happened? Oh yeah, I did some crazy jazz. Oh, it's a lot of work. That's a lot of work. Haha. Divided by second answer. Neither of that is right. In fact, it should be simplifying. The things I do. Okay, unpause. Great. I figured out where I went wrong. And this is, ladies and gentlemen, why you should always do math without recording yourself. Because you will most likely do things wrong. And it is okay to do things wrong. But not for the camera. Apparently, not for the camera. Okay. Let's backtrack a bit. What I wrote down and what I said were very contradictory. And now my computer is deciding to not work with me right now. I said earlier that these would cancel out. And they would have. They definitely should have. And they could have if I had actually written them right. So let's back up and just rewrite the equation that should have been. This is the proper equation. Okay. Now, I need to find... So I'm going to multiply 9 by 16, 144 plus 81. Perfect. That will get me 225 as a numerator here. So that would be 81 over 16 y squared plus 144 over 16 y squared equals 144. We can combine these like terms to find 225 over 16 y squared equals 144. From here, I'm going to multiply from both sides. Multiply 16 on both sides. So 16, 16. And then I'm going to end up with 144 by 16 equals 2,304. 220. Let's just do that. 225. Y squared equals that. Divide both sides by 225. Y squared is going to equal 2, so 2,304 divided by 225. Mine is going to simplify that fraction for me. Yours probably won't, so it's a good idea to set your calculator to fractions mode if you have it, and if you don't, I'm so sorry. And then I'm going to square root both sides. This will become y is equal to, and this is actually not a perfect square. It's not a great square, so we're going to have to write this as plus or minus 256 over 25. Do you want to approximate this? Sure. And you can. That would be equivalent to y is equal to plus or minus 3.2 with just a 1 decimal place roundup. This is also acceptable, but I prefer this just because it's more accurate. There's a box. All right, perfect. I'm going to pause, and I'm going to do the rest of the homework. All right, I am back. So I'm going to skip day 1's homework just because the only problem I even had trouble with was number 38, and number 38 was just because I didn't understand how to substitute. So we're going to skip that, and we're actually going to move into day 2's homework, and we're going to look at 22, 30, and 31. So I'm going to start writing some of those things out. So I'm going to actually pull them up on my phone because I don't remember what they say at all. 22, 30, and 31. Why do I not have those remembered? Hold on a second here. Okay, I realized that Miss Kuntz actually already uploaded those onto Google Classroom, so those are not, that's not what I'm going to do. Instead, I'm going to focus on the very last page of homework, which is going to be grade 3's homework. Okay, so, problems I thought were the hardest. There were a couple, but mainly just because of figures, not actually because of their learning. So let's look at problem number 18 on day 3's homework. Number 18. And I'm going to need to grab a textbook. All right, perfect. Here we go. Number 18 reads, at noon, ship A is 150 kilometers west of ship B. Ship A is sailing east at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Few key things to take note of here. It tells us the distance between ship A and ship B, but it does not tell us that they're like directly apart at the starting position. So that's a good thing to note. Another thing to take note of, it mentions that we're at noon, which is to say that time is essentially zeroed out. So when it's asking us about 4 p.m., we're going to be looking at measurements of distance in terms of the hour past noon. Finally, it gives us rates, which we're going to use both to find those distances and otherwise. So first and foremost, I'm going to draw out an equation of this problem. A figure of this problem. So, I know it's going to be a triangle. Ship A will be here. I'm going to label it A. And over here will be ship B. You might be saying to me, or to yourself, why is ship B not here? It can be, but you're going to have to move it up here to showcase that it has to be at 4 o'clock. Does that make sense? It can be here. This could be ship B, but you would have to showcase it has moved because we are measuring it at 4 o'clock. Which means that from the initial position of A over here, this length X would also have happened. So let's just draw this. Oh, I can't draw straight lines. That's as good as you're going to get. Now this is a 90-degree angle, so we can understand that this is going to have trigonometry. Alright, let's also write down what we learned. So what we learned is that d of A, also known as d of x, right, we'll just call it d of x, is equal to 35 kilometers per hour, measure of distance, measure of time, dt. dy dt, or the rate of change for our y value, is equal to 25 kilometers per hour. And this will technically be negative because we're moving this way. Because it was initially west and we're moving against the flow. Therefore, it must be negative. Alright, perfect. So now that I have a model and some basics written down, I'm going to write out an equation, or I'm going to write out a simple x squared plus y squared equals c squared. If you worked enough with this equation, you'll know just how to find the derivative super quickly. For simplicity's sake, I'm just going to write it. It's c dc over dt. And I'm writing c, but this should technically be z. So I'm going to actually rewrite that in terms of z just so it handles itself better. Z dz dt is equal to x dx dt plus y dy dt. Awesome. Here's the thing. For this triangle, this x here, will be equal to 150 minus x as a move thing. This will be y. So, now that we have all of this figured out, all of this is here now, we now need to actually find what x and y are equal to. Because it's great to have numbers, or it's great to have these values, but because we don't know what they mean, we cannot solve for z dz dt, because that's what we're trying to solve for. We're trying to solve for specifically dz dt. To find the distance between these two, the rate at which they're changing. So this would be z dz dt. We're trying to solve for this. Cool. So I'm just gonna I'm not even gonna bother with that. I'm just gonna rewrite the equation to the side of that. Z dz dt to x dx dt. Alright, cool. So we have all this. Alright. We need to actually solve for x and y. But you may be thinking to yourself, Tomas, how am I going to solve for x and y? Well, we know, and like I said before, we're going to use these rates. We know rates. which is to say 35 kilometers per hour. So if we know an hour after 12, then we know how much distance they've supposedly traveled during that time. So we can do that. We can plug in 4 to this equation, which is to say that would be negative 35 times 4, which is equal to, I don't have this off the top of my head, I'm pretty sure it's 140. Negative 140, I don't remember. Negative 35 times 4. Yeah, negative 140. Perfect. I just lost my pen for like a minute. I was like, huh? Yeah, I did that right. Okay. Cool. Brain is deciding to hurt. And then we're going to do the same with 25. So 25 times 4 is going to be equal to 100 pennies. Quarters. I said pennies. Really? Okay, great. So now we have z dz dt is equal to what is essentially going to be negative 140 dx dt, which we're going to plug in soon, plus 100 dy dt. But we still don't know what z is. Well, my fellow compatriots, you just found 2 sides of a right triangle. So, lucky you, Pythagorean theorem can actually help you here. Z, and it's not going to come back pretty. It's going to be something like 10,100 square root. So, not fun. Not a fun thing to do, but we're going to use it anyways. So, plug everything that I know now into the equation. dz dt. I can't get a pretty d at all. Negative 140. Negative 35. Look at that. Perfect. So we're just going to simplify this all out. So that's going to be negative 140 times negative 35. Look at that. Plus 100 times 25. It's going to be 7,400. That doesn't make a lot of sense. Where did I go wrong with this? Oh, yeah. Haha. Again, these are very impromptu videos. So not many things were actually thought out here. I forgot to do the most important thing here. And that was that when I plugged in my x value, I forgot that technically my x value is 150 minus x, at least for this right triangle. Right? So here I'm just going to substitute it in. That's just bad. Bad, man. So that would be 150 minus what would be 140 squared. Oh, not squared. Haha. dx dt plus y dy dt. Oh, not y though. This needs to actually be just 100. Right? I'm scared now, guys. So now, what would be square root? So it was a 150 minus negative 140, which is even worse in my opinion, because that just means I have to do more work times negative 35. Plus 100 times, I'm going to double check this because I want to make sure my work is bussin'. My work is not at all what I wanted it to be. 150 minus 140 times negative 35. Okay, what happened? That's where I'm... Okay. Yeah, sure, I guess. There's no right way to explain this. This is just going to be 140. I'll be honest with you. Just is what it is. This is 140. Just is. That's all I can tell you. I'm pretty sure just because it's just 35 times 4 positively, so like it's just is what it is. That's just like the distance traveled, displacement, which is always going to be positive, but I won't tell you that that's the exact answer. All I will tell you is that this will actually be 10 negative 35 plus 125, and if you know anything about math, that's going to mean that one of those is going to be super large, one of those is not. So there's actually positive on the other side. And I'm just going to do this kind of quickly. dCdt is equal to, because I'm reaching basically an hour of footage already, Jesus, 2150 over square root of 10,100. You can just leave this here if you wanted to, but you would technically be wrong. You can actually take out 100 from both. And you might be like, Tomas, how the fuck can you take out 100? Look at this, 10,100. That can actually be divided by 100. Crazy. You can take out 100 from this. Anyways, that would look at you. 215. I wrote the answer in my worksheet wrong too. Wow. This is just a travesty all over. 101. And since we got a distance earlier of kilometers per hour, we're just going to write kilometers per hour. Look at that. Clear the canvas. Alright. I already covered a similar triangle problem, so we're going to skip one of those. We're going to move to question 28. Alright, question 28. And I'm actually going to pull up my textbook for this one as well. Oh. Alright, let's do this. Alright, question 28 reads, at noon, ship A is 100 kilometers west of ship B. Ship A is sailing south at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? Now, it reads very similar to the last problem we just did. Very much so. But the way we're going to figure it is very different. Okay, so I'm going to draw 2 starting points and label the distance between them to be 100 kilometers. Now, we learned that one ship went up and one ship went down, north and south. We remember that this will be dy over dt, and we will label this dx over dt, just because I want to keep things very simple. So x, and this will be y. And I mentioned that dy dt was 25 miles, or 25 kilometers per hour. Imperialism for the win, because it said it's sailing north at 25 kilometers per hour. And since y is up north, that will be that. The one is heading downward at 35 kilometers per hour. Now, we need to know 2 things. First and foremost, this distance is what we're solving for. We're solving for the distance. So I'm going to label 2 things. Label the actual line a z, and label the rate of change of that dz over dt. That's what we're solving for. When time is equal to 4 or 4 o'clock p.m. Another thing I'm going to look at here, and this will help us later, is that this is in fact a rectangle. And this rectangle completes part of the rectangle completes this larger triangle, which is actually going to benefit us because the hypotenuse of that larger triangle is actually dz dt. Does that make sense? Like, this whole part of the equation is going to be much faster if we solve for that hypotenuse. So we're going to need to solve for the hypotenuse. So, first and foremost, I'm going to set up an equation. Now, because this length here is equivalent to this length here, because of this how rectangle properties work, I'm going to write just one side of this, x plus y squared, plus a length of time we do know. We do know that the distance between essentially these, or this side, right? We know that this part of the rectangle is equivalent to this part of the rectangle. So this is 100 squared is equal to z squared. Yes. Now, why did I plug this in? I don't need to, but I'm not going to substitute a variable for it. I'm actually just going to let it die. Because, yeah, just deal with that. So, if simplified, this would be 2x plus y inside derivative function dx dt plus dy dt plus 0. Okay, cool. But we've come across the first major blocking road. What is z? We still have a z value, and I didn't even write dz dt. So I'm just going to write it up front here, just because I don't have to rewrite this. We don't know what z is. Well, we do know that this right here in the back up front was 100. And we also know the time. So even if we do not know that, we can solve because we have the rate of change for y and the rate of change for x. So what we're going to do is we're going to essentially take this equation, make a separate offshoot of it, like I've been doing for a while. And I'm just going to solve for x and y, and then plug them into the equation and square root it to solve for z. So let's do that. All right, so x. Well, x after 4, so the rate of change after 4, that would be 35 times 4. And if you remember the question we just did, that would be 140. And same thing as the last question, 25 times 4, like a fucking dollar, we're going to get 100. I should not be swearing in a supposedly sanctioned video. Now, that's going to be 140 plus 100 squared plus 100 squared equals z squared. That means z is going to be equal to 140 plus 100 inside parentheses first squared 57,600 plus 100 squared, and the square root of that 67600, that's the total, is going to be 260. That's a perfect square. So I'm going to put it as 260. Great, so now we actually know what z is. So dz, why did I do that? I'm just going to simplify it out, so that's 260 dz dt is now equal to 140 plus 100, 25 plus 35. Awesome. Now we actually can solve, because now we're just going to be doing some algebra. We only have one real variable, and that's dz dt. So 2 times, in parentheses, 140 plus 100 times 25 plus 35. Add all together is going to equal 28,800. And dividing that by 2 by 260 will be equal to an improper fraction of 720 over 13. That's why you should always have fraction mode on, of dz dt. And can we have units for this? Yes, we can, because we know that kilometers per hour was a unit earlier. So this will be kilometers per hour. Perfect. All right. Let's do one more question. I think I want to do one more question. And that question is actually going to be question 46, just because it works with a triangle that we haven't worked with before. So let me read question 46 off to you. All right, question 46. Two sides of a triangle have lengths 12 meters and 15 meters. The angle between them is increasing at a rate of 2 degrees per minute. How fast is the length of the third side increasing when the angle between the sides of fixed length is 60 degrees? What's it percent? Jeez. Alright, so that's a lot of information taken. First and foremost, I'm going to draw a picture. So it said a triangle. It did not specify if it was a right triangle, if it was an equilateral triangle, or isosceles. So it's a triangle. Because of that, I'm just going to assume it is kind of like one of these guys. Just kind of those like weird lumpy triangles. We don't really like them. They're not really fun for us in geometry, but we sure as hell are going to need them. Alright, so now I'm going to label any length. I don't care which length you decide to label, but you need to make sure that there's an angle between them, because we need to be working with angles here. This is one of those angle problems. I'm going to label this side x, it's an unknown, and I'm going to label my angle between these two theta. Alright, now I'm going to write down some things that the problem gave us, and I forgot to write down what number we're on, so I'm just going to do that right up here. Alright, so the problem gave us that d theta dt, or the rate of change of the theta, or the angle, is 2 degrees per minute. And I don't like 2 degrees per minute. You may be thinking to yourself, whoop, whoop, we're finally working degrees. No. Degrees are a pain to have to work with. But that's okay, we're just going to trudge through it. Another thing it told us is that we're going to be doing this when the degree, or theta, is equal to 60 degrees. We're going to solve for when the angle between the sides of fixed length is 60 degrees. Cool. So now we know what we have. So first and foremost, I need to actually solve. How do I start solving for things? Like, how do I start setting things up? This is where your good old friend, the law of cosines, comes in. Now, if you're not in physics and you haven't had to look at the law of cosines forever, this might be a big refresher for you. And it would be ideal to take a look and start figuring out what you're going to need to do for this, because it's going to be very important later on, at least for these kinds of problems. So, because we're in such a geometry related unit, this would be very important to start reviewing. But I'll write out the law of cosines for you. The law of cosines says that this side, a side x squared, is equivalent to these two sides, otherwise known as a squared b squared, minus 2a times b multiplied by cosine theta. And now we just need to kind of start substituting in. We can substitute it in. I mean, I guess if we need to. Yes, we should actually substitute it in. So, first and foremost, x squared is equal to 12 squared times 15 squared minus 2, 12, 15 equaling cosine theta. And I'm not going to plug in our angle just yet, because I don't want to just yet. I want to use it for later. Next, I'm going to start simplifying. So this will become 144 times 15 squared. I don't know 15 squared off the top of my head. That's going to be 144 times 15 squared. That's going to be equal to 32,400. I'm just going to erase that because I don't have to deal with that. And I'm actually going to... Yeah, that makes sense. Just to like review my work. 2a times b, so that's minus 2 times 15 times 12. Why do I have 300? Am I doing the law of cosines wrong? Hold on a minute here. That's embarrassing. Okay, so Here's something I forgot about the law of cosines, and I'm just going to fix it up here. This is actually a squared plus b squared minus 2ab. So this would actually be 144 plus 15 squared, which is 225, minus blah, blah, blah. Cool. Great. So if I were to simplify this problem out, that would be 144 plus 225, which is equal to 369 minus 360, because 2 times 12 times 15 is equal to 360 cosine of theta. And you might be tempted to minus, but because it's attached to a variable, we cannot. So we're going to now simplify by implicit differentiation. So that's going to be 2x dx dt is equal to 0 minus cosine theta. What's the derivative of that? That's negative sine. That's going to become positive sine. And before we do that, I'm actually going to put the number before everything else. So 360, because a constant times a function is equal to the constant times the derivative. 360 sine theta. Alright, perfect. That looks fine, I guess. Oh, d theta dt, because inside function. Alright, cool. So now we get to start simplifying. Now we really truly get to start simplifying. Okay. So to simplify, just put dx dt over here by its lonesome, because we're going to divide by 2x. This will become 100. So this will be 360 sine of theta over 2x. We're going to put times d theta dt. That's just the easiest way to do it. And these are just going to cancel out. So this will become 180. Let's just become x. So I'm going to rewrite that over here. So, here's the deal. Here's the dung diddly deal. Because we can do this, I don't know how to explain how the right way to explain it is. We can do this with degrees. I'm not going to. That is just my choice. If you choose to do this with degrees, congrats to you, but I like not having degrees. So, because of that, we need to actually simplify a good chunk of that, right? Because we can't just be having, we can't just be having this whole random part. It just doesn't make a whole lot of sense. So, first and foremost, I just realized something that I actually really have to check on. Why did I just drop my pen? No reason. No rhyme or rhythm. I'm going to check really quickly. And wow, I actually hit an hour. Where is this? 46. Oh yeah, I forgot to totally outline that part. There's two things we don't have. We do not technically have x. We don't have x. We still need to solve for x. We still have to solve for x. We also need to convert this to radians. So I'm going to first solve for x. I feel like that's the easiest of the problems. So we earlier found that x squared was equal to 369 minus 360 cosine of theta. Would you look at that? We have a use for part of our angle. So that will be x squared is equal to 369 minus 360. And what is 60 degrees? What is the cosine of 60 degrees? Cosine of 60 degrees, if your calculator is in degree mode, or if you're really good at the reverse engineering the Pythagorean for some reason, will get you 1/2. And now you're at the part where you're like, oh my gosh, this is so easy. Because now you have 369 minus 360 times 1/2. If you're just a math god and remember that it's 180, then you could find that x squared is equal to 189. So if we square root that, we're going to find it's the square root of 189. Cool, so now we know x. But we also want to have d theta dt coming into the next part of the equation. So I'm going to move over here, and I'm going to draw a unit circle. So what's one of the big things we know about the unit circle? Other than that, it's a never-ending nightmare. And this is pi over 3. I said that wrong, didn't I? Yeah, I did. Oh my gosh. Pi over 4. So pi over 6. Now, I'm just going to do it as the cosine of pi over 6. And your calculator should most likely be in degree mode for this. Or radian mode for this. No, is it the sine of pi over 6? Or pi over 90? Oh my gosh. Sine of 2. Delete. Wait a minute. Sine inverse of 2. Pi divided by 90. Oh my gosh. Is it cosine of 2 degrees? But this should actually be degrees. There we go. Okay. That makes sense. So, the rate of change of an angle, because angles work as y values, because when we're looking at this, this is a y value on essentially what is a graph of, a curve. We're going to use sine. And we're going to find sine of 2 degrees. So sine of 2 degrees in degree mode is equivalent to pi over 90. And I didn't pull this out of my ass. It's going to be pain to try to solve this. And I'm going to wish you best of luck, and I'm going to hope that this never appears in the test. But it's pi over 90. Alright, so now we know essentially what our dt is in terms, or d theta dt is in terms of radians, and we know our x value. So now we're going to just do a good old-fashioned plug in. Dx over dt is equal to 180 sine of 60. We're finally going to plug in those 60 degrees over square root of 189 times pi over 90. Alright, so what's sine of 60? Let me tell you, it's not a good thing. In fact, it's square root over, the square root of 3 over 2. That's what sine 60 is equal to in exact value. So, that's not necessarily something I expect you to know, but that's probably something you might be expected to know on the test, so good luck with that. So now I'm going to have 180 square root of 3 over 2 over square root of 189 times pi over 90. We can simplify this fraction. or this radical. We can actually pull out a 9 from that, and that will leave us with, so this would be square root of 9 times, what is it, 189 divided by 9 times the square root of 21, which would be 3 square root of 21. This is breaking up the radicand. So now we have dx over dt is equal to 180 square root of 3 over 2 over square root of 189. Oh, wow. I did that and then just buffed again. Crazy. 3 over square root of 21. Alright, so we need to divide by pi over 90. As you can tell, it's late o'clock for me, which is why I said late o'clock. Alright, cool. So, me trying to figure out how I explain this. These can cross multiply, so this will become 2, and this will become 1. Don't make a triangle right now. That is not what I wanted out of you. Oh, okay. I don't have any control over this keyboard some days. 90 is crossed out 1. And because we have a 2 here, these 2's can cancel out. So that will become, after some simplification, a square root of 3 over 3 square root of 21 times essentially what is pi. Now what I'm going to do is a little obscure, a little not fun, in my opinion, but it is necessary. 3 as a square root can be added, or can be multiplied with 21. So I'm going to multiply I just have to work through this problem on my own for like 2 minutes. Oh yeah. Okay. Yeah, so I'm going to multiply this by this. Okay. So, I'm going to have is square root of 3 dx dt is equal to square root of 3 pi over 3 square root of 21 square root of 3. And I'm now going to divide. They might be like, Tomas, you just multiplied, why are you dividing? Because I still want to have dx dt by itself. I just want to watch the world burn. This will become now hold on. That logic was not right at all. That was supposed to be logic? And that didn't work. Oh, I have to do the radicand. Okay. Fine. I guess I'll have to do it the way I know how to do it. So be it. Times what is essentially pi. I don't know why File Explorer can't. What is essentially pi. Okay, so first and foremost, I need to do something about this. This is pesky. I don't want this right there. So, I'm going to do this square root of 63 over 3 times pi. So I just multiplied 21 on both sides. Blah, 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 blah. Square root of 63 over 3. Now, here's the problem with that. I need the radicand on the bottom. I do need it on the bottom. So, what would essentially be all of that. I forgot what the reasoning was. I did the reason before, and I wish I could recall that. I'm gonna try to pause real quick and review why that's right. Okay, so what I did was not wrong. It's just not what the answer key will want you to do, and I will explain why. So what I did is I multiplied the radicand on the bottom, because from what we were taught, you must multiply the radicand on the bottom. And if you do this, we will end up with square root of 63 up top with 63 on bottom times pi. And with this, you would be correct, because you would put the pi up top and not write it up here, and this is right. However, the key wants you to have it as pi over square root of 63. That is technically considered an improper radicand, because if you have this, you would be obliged to multiply by the square root of 63 on both sides. And that would make this equivalent to the square root of 63 pi over 63, where I wrote as my answer here. But they tend to want you to have the more improper answer. Rather unfortunate for those of us who do actually enjoy finding the right answer, but not so much unfortunate for those of you who don't want to do that much work. Finally, it did give us, and wow, I did the wrong measurement, didn't I? I'm literally going to criticize myself if I just did the wrong measurement. Wow. Ready for the laughs, guys. I didn't do the wrong measurements, did I? Did it read? Maybe I just didn't read. I didn't read. Oh my gosh. Oh my goodness. Embarrassing. Where's that figure I drew? I put centimeters? Haha. Okay, well that's wrong. That's actually in meters. In meters per minute, because it told us that radians was in meter, or in radians per minute. Therefore, minute. Awesome. Awesome. Alright. So, that has been what I would consider to be the hardest problems on day 3's homework and the review. If you want, please feel free to contact me tomorrow during school, or also during math class, any other time. I'm more than willing to walk through problems and help out in that way. I probably won't be running through the Desmos, because the Desmos doesn't seem chock full of too many hard problems. But if enough people tomorrow tell me that they want me to run through the Desmos as well, I can also do that. So please let me know if you have any questions regarding that. And so, with that, I'll see you all tomorrow for school in Calc, unless you're obviously out with COVID, in which case, get better. And, yeah.